Today we are going to learn about the topic called recursion. Before starting this session, I want to know how many of you know about the factorial. Suppose I want to calculate the factorial of 5. How you calculate? From this group?
5 factorial, 5 plus 4 plus 3 plus 2 plus 1.
Okay. And when you get the 1, then what you will do?
1.
What is the factorial of 1?
1.
Okay. What is the factorial of negative number?
Negative numbers.
It is not defined. Yeah. Okay. So a negative number factorial is not defined. You should know about it. So have you joined this?
Yes, sir. Yeah.
Okay. So I want to check your previous knowledge because before this topic we already learned about functions and the loops. You should have some basic knowledge about this thing. To check your knowledge, first you have to come through this. Okay. Yeah.
We'll answer as a team.
Yeah, you can answer as a team. You will work in a pair. What is the main purpose of function in programming?
Use coefficient 2. There's second. 2 operation. 6 options.
Okay, time is up. The correct answer is the second one, to organize and reuse code efficiently. That is the correct code here. Yeah. Come with the second question. What is the primary difference between iterative and the recursive approach?
Plus 2.
Okay. Yeah, time is up. Oh, very good. You know about iterative approach use loops and the recursive approach use function calling. Okay. So before starting our session, we get to know you have something known about recursion and the function itself. Okay. So by the end of lesson, you will able to identify what is the best condition and what is the recursive condition. And second thing, you able to apply the principle of recursion in any of the problem situations. Okay. So, what is the definition of the recursion? What is the definition here? When a function call itself until a condition is met. This is, for example, we have learning about the factorial. So, when I say you have to stop, when you get the number 1 or 0, you have to stop that time, but you cannot get the factorial of negative number because it is not defined. The same way, one Russian doll is there, you are saying that one in the larger size, another one in the smaller, and the problem, because suppose we are calculating the factorial of 5, we cannot solve it. First we should know about 4, then we should know about 3, 2, 1. So you should know how you can divide your problem into sub problem. And second thing is, you have to provide the stopping condition, where I have to stop. What should be my stopping condition? Suppose in case of factorial, the factorial of 1 is 1, you have to stop it, because when you are going towards negative number, the negative number factorial is not defined. Okay, so we are taking one example here, the calculating the factorial of any number. So you are seeing here, what is the best condition here? When the value of n is 1 or 0, you have to return 1, because factorial of 0 is 1 and 1 is 1. And what are the recursive condition here? N multiplied by factorial of n minus 1. That means 5 multiplied by factorial of 4, 4 multiplied by factorial of 3, 3 multiplied by factorial of 2, 2 multiplied by factorial of 1, 1 multiplied by factorial of 0, and the factorial of 0 is 1, and again we are getting the result back to the 5, though the 5 factorial is 120. So this is the recursive stack. And when we are not mentioning our best condition, then what will happen? Can anyone tell me? When I am not putting any base condition, I am not putting any stopping condition here, then what will happen?
It will keep on. It will keep on executing.
It will keep on executing until memory is there. When the memory is occupied, the one problem is there, which is known as stack overflow problem. Your stack is completely occupied. So whenever you are dealing with the recursion, what you have to know?
Where to stop?
First one is the base condition and second one is how you have to divide your problem into the sub problem. The two things are required. First thing is the best case, and second one is the recursive case. Best case means stopping condition, and recursive case is calling the smaller sub instance of the same problem. Okay, so now you are able to identify best condition and recursive condition. Now again come back to the booklet. Now we have some question related to identifying the base case and the recursive case. You come with, okay, the first question is, which of the following statement correctly identify the base case in the given example?
You just go to the.
Okay, yeah,
You just go to the QR.
this thing is there, yeah. You have to identify the base case, means stopping condition. Okay, good,
First.
yeah. Okay, time is up. Okay, everyone participate, and your answer is correct, because the stopping condition here is when n is 0, you have to return 1. Okay, just participate in the second question. What is the recursive case to calculate the greatest common divisor of two numbers? The GCD program is there. If b is 0 is a, and GCD of b a modulus b. So what should be the answer here? Okay, 1. Everyone should participate. You can work in a pair. Yeah, 1, 2, and this pair should be there. Yeah. Okay, good. What you have done? Okay, yeah, everyone have chosen the correct one. Okay, who has choose the first one? Just raise your hand. Okay, what's your thought behind the option 1?
Basic condition of whenever.
We have asking about the recursive case.
Oh, recursion.
Okay, you have to correct it, because in the recursion you are mentioning the base condition there. Yeah, okay. First you have to listen about the question first. Yeah. The next question related to this one again. Okay, you have to again find out the base condition. So what should be the best condition here? Yeah, everyone just work in a pair, discuss and answer. Best condition. Okay, yeah, means everyone understand about the base condition, means where we have to stop. And what about the recursive condition? Where we have to call the same instance of the same problem. Okay, now we are moving towards our activity number 2. Okay, yeah, now I am providing you some piece of papers. You have to work in a group. You have to identify the base condition as well as the recursive condition of the given program. The program is the sum of n numbers. Suppose number is 5. So how you calculate? 5 plus 4 plus 2 plus 3 plus 1 is equal to 15. So when I am saying n is equal to 1, so you have to return 1. When n is equal to 2, then you have to return 2 plus n minus 1. Same way you have to write both the cases, base case as well as recursive case. Yeah, you can discuss with your pairs and propose some solution related to this. You have to divide two cases. Base case means stopping condition where your program should be stopped, and second thing should be recursive case. Yeah. Yeah, and this one, written one. Okay, very good. Okay, recursive. Okay, you just cross check your answer with the given solution is there. When n is less than equal to 1, you have to return and yeah. And whatever the recursive call, n plus
N minus.
sum of n minus 1. Understand? When we are calling for 4, then what should be the call? 4 plus sum of 3. For 3, 3 plus sum of 2. For 2, 2 plus sum of 1. 4 plus 1. 1 plus sum of 0, and finally you have to return 0, and you can get back the answer is 15 when you are calling for the 5. Okay. Now we are going to conclude our lesson. So this should be the last. Just again come back to the book. Whatever you have learned, you have to justify here. Okay, the question is, which of the following statement is true about recursion? This is a multiple choice question. You can select many options are there. Okay, you can discuss again in a pair and finalize the solution. Okay, what you are doing?
First two is done, sir. Second one, the rest of the two we are just.
Okay.
Recursive.
Okay, now we are concluding our lecture. Okay, two have selected this, two have selected this, one have selected. All options are correct here. We are just have a quick revision about it. The recursive function is when a function call itself. You know about this. What about the second one?
Yes.
Base condition means stopping condition. That should be required here. Okay. What about the third one? The recursive function can be less efficient than the iterative function due to the function call overhead. Because we have to maintain the stack. When we are calling 4, then we have to maintain for the 3, then 2, then 1. So more overhead will be there in case of recursion. And whatever you are doing with the recursion, you can do with the iteration, as you learn in the previous topics. Okay. Thank you.
Thank you.
Thank you. Thank you.
Thank you. Maybe we'll go around to give some, share your experience of the lesson.
Interesting session, and we are entirely understanding about the concept of recursion.
I took away the taking from this lesson is that how an assessment can actually lead to a discussion among the students.
Yes.
So this is the takeaway.
The assessment technique is very engaging.
Okay.
It helps us, like, although we are not from the same background,
Okay.
but still, we were applying our brains to get the right answer, although we were cheating too.
Okay.
It gives us
Yeah, Harshit, it's actually engaging. It's very, and the code you explain, and you're not deep diving into the code. Though you gave a piece of paper, we thought we are afraid of you are asking us to write code.
Yeah.
And instead of that, you just make it simple for us so that everyone can answer.
Yes.
So the questions are simple. That actually make us okay. Let's participate. Let's not skip. So I really do appreciate that.
Apart from everything that has been covered already, I like the part that you planned your lecture very well. I
Okay.
think you had it all set
Yes.
in your head,
Yeah.
what is when, and you adhered to the time. This is my takeaway, that that the lecture was planned.
Okay.
Very well planned.
Thank you.
Yes.
Thank you. Thank you.
Yes, I second that actually. It's very pedagogical. So I'm just going to ask you again, if you have 5 more minutes, what will you do?
So I will implement all things through practical implementation. Generally, I take the coding classes. So what the program that I am explaining you, I just do the regular live coding in my regular class.
Okay.
So the problem that occurs is stack overflow. So I generally do this problem and again ask to the student, what is the problem here and how can we rectify this problem. So I will basically do this thing in my regular class.
Okay. So actually, there are also opportunities to be there to go even further, because even from the factorial, yeah, maybe some of the students would even be able to come out with the key points themselves. Actually,
Yes.
yeah. So, but of course, I mean, this is a choice depending on how well the students are.
Yes.
And but I think your approach is actually good, because there is a very explicit instruction, and then you see whether the students can demonstrate whether they have learned, like in the first
Yes.
5 minutes. So I think it's a good check, and you have multiple checks along the way.
Yes.
Yeah. So I felt I think I should give you 5 or 10 more minutes, because it's a little rush, but I think a lot
Yeah.
has been accomplished in 10 minutes.
Yes. Yes. Sir.
Yeah, I agree with all of that, and I think that what I noticed that you did different, like you did was that you actually tried to check the prior knowledge of the students
Yes.
before you started the lesson. I think that's quite useful actually.
Yes.
So I guess the question is, what happens if you have a class where some students are, not brainiacs, right? And perhaps you already made it very easy, but what happens if you notice when they're discussing there are some students who are struggling? I'm just curious to know how you would address that scenario. Yeah.
When students are not doing anything,
Like when the students are struggling, say like for instance like me and
okay,
him pair up.
I will assist them. I will just go through their desk and explain the same thing in a very simpler way. I just took the very easiest example so they can correlate the same thing with the things that I am teaching to them.
Yeah, thank you. I mean, I guess like that you've already done that. I think you mentioned that the activity was actually quite simple. So I think the ability to lower the intimidation level is quite helpful.
Yes.
But do have a think about, you might have students with they are moving at different pace, and how so the thing about quizzes like that is, if everyone else, like let's say I don't get it, but all my friends like, okay, yeah, they got it, and then we move on, then I'll feel afraid to say that, oh, I don't quite understand that bit. So for all of us to think about how do we cater to students who are a bit maybe need
Because
some help.
here the time is very lesser, so we have to quickly rush to the next topic. Otherwise, when the class is there, then we really ask the student queries and understand each and every question, every topics to student until they have learned they will be in the same phase.
Yeah, exactly.
So we don't have to be pressured to be the one giving the answer because you're sitting next to people. So even those who cannot, so we can make use of, because if more than half your class get the answer correct, the probability that someone who doesn't know the answer sitting to someone who knows the answer is very high.
Yeah.
That's why I just make
Yes.
sure they are working in a think pair. So
Yeah,
when
yeah.
one know, they can take the help from the neighbor person. So it will be more like collaborative kind of thing.
Yeah, I like that as well, that you give them the option to work together. Yeah,
Yeah.
I thought that was good.
Yes.
Okay. Yeah.
Thank you.
Thank you.
Thank you.